Okay, so what we've worked on this morning is like, how do we know how many digits we're measuring to, right? So how we measure properly is all the digits we know plus one more that we don't know, okay? So when we measure, we call those significant figures, okay? So that's just the minimum number of digits to report a value without loss of accuracy, right? So when you measure, you want to make sure it's every digit you know plus one more. If we have a tool that can get you to the hundreds place, do we need to actually go to the hundreds place and not round to a whole number? Okay, so we want to make sure we're being as accurate as possible. But on the flip side, let's say we have a beaker and it only measures to the tenths or to the tens place. Can you write something that's like 461.7? Okay, so on the same level, if you can only measure to the tens value, you can't over measure because then you're making up numbers. Okay, so when we take measurements, it's called significant figures of including like the appropriate numbers. Okay. So today our goal is just to learn how to count significant figures. I gave you a little space to write, and what we basically want to do is include all of this. Picture 2. So I used to have like a long list of rules, and then last year I found this picture, and I think it makes life easier. So like we are going to copy most of this picture in your space. Okay. The only rule that didn't fit in the picture is this non-zero one, which is the easiest one. So any non-zero digits are always considered significant digits or significant figures. So for example, the number 356, there's 3 numbers there, or there's 3 significant figures. Okay, or I just say SF for short. Okay, then in that space, we are going to put these rules down, and I'll like underline, I think, what you should write down. So then the next rule, we call it the sandwiched zero. So that could be rule number 2. Maybe we'll make that rule number 1. This is rule number 2. A sandwiched zero is if it's in between 2 non-zero digits, right? And like, does that make sense? It's sandwiched. Does that make sense? Okay, so let's say you have the number 402. There's 3 digits there, or there'd be 3 significant figures. Okay, so for you on your notes, write sandwich 0, and then you could just do the example 402, and it's going to equal 3 significant figures. Okay, our next rule, I'm going to change colors so don't overlap. Okay, the third rule, trailing zeros with a decimal are significant. The key for this one is like with a decimal. Okay, so write the whole thing down. But then maybe you need to like highlight or star, underline. The key for this one, if a decimal is present, those zeros are going to be significant. So, for example, if we have 3.00, okay, how many numbers are there? Or how many digits are in that number? 3. So this one would have 3 significant figures. Another way I like to think about this one, if you take the time to write 3.00, like if you take the time to write that 0.00, are they significant? Yes. Okay, so like just kind of remember, if you're writing 3.00 instead of just 3, like those are significant zeros. Okay, rule number 4 is trailing zeros without a decimal. Okay. The key here is without a decimal. These ones are insignificant. So maybe write, like, add insignificant in your notes. So, for example, the number 3,000, this time there's no decimal point there. Those zeros do not count as significant figures. Only the 3 does. So this one only counts for 1 significant figure. And then rule number 5, leading zeros and a number are also insignificant. They're just placeholders. So like 0.07, these two zeros are not significant. Only the 7 is. So this one is only one significant figure. So now we're just looking at like basically these zeros. Like why are zeros sometimes significant? Why are they not significant? Okay. So the digit of 0 at the end of a number is considered significant if there is a decimal. Okay. So I'm going to show you an example. So here's this line on the ruler. If you had to read this line, what would you read it? Like what's the length of this line?
50 centimeters.
Okay, and it's every digit you know plus how many more?
50.0.
Okay, do y'all agree? Bless you. Right. So do y'all agree this line, is it exactly at the 50? Okay, but we have to go one digit further, so it's 50.0. Okay. Because it's exactly, like, do we have a tool that can measure to the tenths place where we know it's 50.0? Yeah. Okay, so because we can actually measure this, and we know this is like exactly on the 50 line, it's 50.0, all of these zeros are going to count. So all digits count here. So there's 1, 2, 3 significant figures. Okay. Okay, so now look at this line. What would you measure this line to be?
50.
Okay, roughly 50. Are we certain it's 50 or did we even have to guess?
Yes.
We had to guess, right? Is there a line on the ruler that tells us it's 50? Okay, so this is a guess in general. Okay. So this time, we're not even certain this is 50 something, right? Could it be a high 40 or could it be like a low 50 something? Okay. So even though there's 2 digits in this number, because we're really guessing on the 5, this 0 is not significant. Okay. So only the 5 is a significant digit, and there's only one significant figure in 50 without a decimal point. Okay, there are a couple exceptions when we count numbers for significant figures. In your notes, for sure write the red. Okay, so like what I put in red, write this down. Okay. The first one is counting numbers. If it's a small enough quantity that you can count an exact number, there's no guessing, right? So like if I were to count the number of people in this room, there's 25 of you, okay? Am I guessing that last number or am I positive there's 25 of you in this room? Okay, so an exact count doesn't count as significant figures because could I write 25.00000? Are there exactly 25 of you? Okay, I could write 25.00000 for forever, okay? So those don't count. For counting numbers, we would say that there's like an infinite amount of Sig Figs because I could write 25.00000 because it's exactly 25 of you, okay? We're going to start doing some conversions maybe on Friday this week. So the number 1 in a conversion factor doesn't count for significant figures. So what I mean by that is like 1 mole of hydrochloric acid is going to weigh 36.56 grams. Does 36.56 look like it came from a measurement? Right, does that look like someone put on a balance and measured it? Okay, this number counts for significant figures, but this number 1 doesn't. Okay, so like we would basically ignore the 1 when we're doing significant figures. I think we'll start these conversions Friday. When we get to conversions, like I will show you what this means when we're there. Okay. And then the last exception are definitions. Okay, definitions are measured. So like a dozen is how many? 12. Okay, in our like society, have we just agreed that the word dozen always means 12? Okay, that's not a measurement, that's a definition. So if we were using like the number 12 as a dozen, like that doesn't count for significant figures because it wasn't a measured number, right? That's a definition. Another good one is like a foot is defined as how many inches? How many inches are in a foot? Okay, that is a definition. So again, those don't count because they're not measured like inches and feet when we created them. 12 inches is defined as a foot. Okay. How many Sig Figs are in the following measurements? So you can say it out loud, but I want to see everybody's fingers because I want you all to participate. So in 123, how many Sig Figs? Okay, I want to see everybody's fingers. How many Sig Figs? 123. Okay, all non-zero digits are always significant. So how many Sig Figs on this one? Okay, 3 Sig Figs. How about 0.123? Okay. Take a guess. Put your fingers up. Low stakes if you get it wrong. So I want you all trying right now. Okay, this is the rule. Leading zeros don't count as significant. Okay, always non-zeros do. So how many Sig Figs should we get for this one? This one should be 3. Okay. 40,506. Good. Okay, this is the sandwich rule. If zeros are sandwiched, are they significant? Yep. Is this one also sandwiched? Also significant. So how many Sig Figs for this number? Are we getting 5? Okay. 9.8000 times 10 to the 4th. Take a guess. Stakes are low. Okay, this one, when we read scientific notation, the times 10 to the 4th doesn't matter. Okay, but this part does matter. Okay, so if we look at this part, if you have a decimal, do the zeros that come after the decimal, do those matter? Are they significant? Yes. Okay, so if they come, remember it's like, if you take the time to write 9.8000 instead of just 9.8, do these have to be significant if you took the time to do that? Okay, so how many digits are here? 5. Okay, so this time it's 5 significant figures. All right, how about 4.5600? Okay, same rule. If they come after the decimal, are they significant? Yes, so we should be getting 5 for this one. 22 meter sticks. This is that tricky one. Is 22 a small enough number? Could I count if I own 22 meter sticks? Okay, a small number that I can physically count to, that's an infinite. That's a terrible infinity symbol, everybody. It's an infinite number of significant figures because could I write that as 22.000, right? That's an exact number. Okay, here's a tricky one. 0.07080. Take a guess on this one. I'm combining lots of rules here. Okay. Leading zeros, do those count? Okay, leading zeros don't count. Okay, after the 7, there is a decimal here. So after we get that first non-zero digit, do these count? They do. So the 7080 count. So how many Sig Figs? 4. Okay. All right, 98,000. No decimals. Okay, I see some of you. Some of you look like you've dwindled here. Okay, this one is only 2. If there's no decimal place, zeros at the end of the number are not significant.